Good afternoon, everybody. My name is Pompilio Araújo. I'm a PhD student at the Federal University of Bahia. I will talk a little bit about our work, that is ARISLAN, a visual stereo indoor simultaneous localization map system for aerial quality control. This is outline of a presentation, introduction about the problem, contribution, ARISLAN system, ARISLAN, environmental representation, tracking, mapping, and conclusion. The ARISLAN is a feature-based SLAN that gets information of environment and estimates the camera pose. We implemented the map maintenance to increase key points while the camera moves. Monocular SLAN and stereo SLAN. This is the problem that we try to resolve. In monocular SLAN, initial camera move is necessary to get to build the start reference map. On the other hand, in stereo SLAN, it's not necessary. We can get the initial map in the first time. We also have redundancy of information of environment. That is, the object is projected to two images in different views. The redundancy reduces the possibility of any noise or disturbance affect the system. In stereo configuration, we always have the same scale, and the monocular SLAN, the scale will depend on the speed of the initial speed of the camera. In stereo configuration, you need to match point and point on the right and left image. This increases CPU cost. We have introduced a new search method to improve this performance. We present three contributions. First, new method of the point matching, starting at probably location of the point and gradually increase the search area. Second, a mapping procedure using three quality indicators to move, to remove or include new points. Last, the map maintenance is made by zone. On the distribution of points is uniform as possible. Tuning process to estimate better. This image summarizes all proposed methods in 5 steps. The input of system is a pair of images, and the output are the camera pose and the map. Before I start to talk about the method, we like to represent the environment. Camera pose as position and orientation is represented by vector of 60 degrees of freedom. We use this representation in homogeneous transformation methods. The map is represented by a set of points, key points. Each key point has the coordinates, descriptor vector, and the three quality indicators. The acquisition of the image is done by a system Tara stereo camera. Tara stereo camera has two similar cameras with equal focal lengths, side by side in no distance, parallel optical edge, semi-image plane, simultaneous acquisition. The first step is to get point of the image of the environment. To detect key point, we use the good fit to track method. We tested 5 methods. The orientation fast and good fit to track have present the best performance. The good fit to track method proved to be better for us. It has low detection time and get a high number of points. To detect some key points, need to descript, need a digital format. The comparison made in the work of the science showed that Airbrief has a better performance and short detection time. Now we show the method for matching points. For each new pin of incoming frame, we tracking process is the tracking process is carried out with comparison between right and left frame and the search and comparison characteristic of new frame and the map keyframe, map points. In this image, each square, red square, represents a pixel detected as a map key point. In new frame, new points is detected to be compared with map points. We represent this square in green color. To match these points, it's necessary to estimate the a priori camera pulse. For that, we use the Kai velocity model with 0.9 dB. This image we represent a radian of the frame. The yellow square represents all pixel analysis of the map. NuPy performs the search in each pixel around. We performed a preparatory procedure to shorten the circle time. In the left, we show the search without the preparatory procedure, and the right we show we use the preparatory procedure before search the description. After that, we have the semi-association pixel pair. We need now to estimate a new camera pose. We use the robust statistical method estimation to obtain the pose that represents the small distance between the points. And a camel filter is used to smooth the estimation only after we get the camera pose. In first step, we fine iteration is performed. In this pair of points, the pair of points with greater distance are eliminated. In new stage, with 10 iteration is done, and at the end, the pose will have the good estimation. In this video, show the implementation of real-time tracking. The blue line shows the connection between mapping points and current frame points. Map procedure rely on the creation of the initial map and sequential map maintenance. The mapping is done in another slower thread. We do the quality analysis of the point by zone. And the points can be added or delete. The map is created with the system startup. The first time frame is on the right and the left is used to create initial time. A matching between points of both frame is performed calculates z coordinate. Points recombinate at the least 8 frames are included in initial map. Map maintenance is based on quality indicators. Each map or key point stores quality indicators. There are 3 indicators. The first one is detection rate in the last 30 frames. The second indicator is based on the Hamming distance. The smaller the distance, the greater indicator. The last indicator is inversely proportional to the error of any estimation algorithm. In this video, the light red color shows the point with good quality, and the bad dot shows the poor quality. The map analysis is done by zone. There are 48 zones. Areas with no points or few points are considered the poor zone. On the other hand, area with more than 20 points are considered rich area. New points found in poor zone can be added to the map. Points with poor quality of the rich zone can be deleted. In this video, you can see the map maintenance by zone. New blue point begin edit and the map point in yellow begin delete. We conclude by showing the experiment done with Phantom 3 Pro. We are working now on the loop closing method to increase map accuracy in larger environments. In the future, we can use it by zone approach to detect the key point by adaptively adjusting the detection threshold. Thank you for your attention.
Okay, we have time for questions. Please go ahead.
How do you deal with some dynamic objects?